in bracket a squared minus s squared plus a squared over 2 sine inverse of s over a plus c. Question 16. Evaluate the integral 1 over square root of a squared minus x squared ds. Solution. Put s equals to a sine theta, which is equivalent to the same thing as theta, making theta the subject of the formula, is equals to sine inverse of s over a. Therefore, the differentiation of the theta is the s over the theta, which is equals to a cos theta. The s, making the s the subject of the formula, we now have a cos theta times the theta. Therefore, from the question, integral of 1 the s over square root of a squared minus s squared will be equals to integral of 1 over a cos theta times a cos theta d theta, which will give us, if they cancel out, we now be left with integral of the theta, which is equals to, if we do the integration, we now have theta plus c. But this theta, if we substitute theta, we now have sine inverse of x over a plus c. If 1 over s squared plus a squared is represented in the integral, use the substitution. S is equals to a tan theta. The s is equals to a sec squared theta d theta. S squared plus a squared is equals to a squared tan theta squared theta plus a squared, which is equals to a squared tan squared theta plus 1, which is also equals to a squared sec squared theta. Question 17. Evaluate the integral the s over s squared plus a squared. Solution. Put s is equals to a tan s. From the right angle triangle we have done, we have observed that s is equals to a tan theta. Therefore, if we do the differentiation of s, we will arrive at the s over the theta is equal to a sec squared theta. But if we have joined two steps, we now have, and make the s the subject of the formula, we now have a sec squared theta d theta. Therefore, the integration of the s over s squared plus a squared is equals to the integral. Then you substitute the s, which is a sec squared theta d theta, over, since previously we have gotten our s squared plus a squared to be a squared sec squared theta, then we substitute to have a squared sec squared theta. Then they will cancel out, a will cancel a to leave us with 1a, and sec squared theta will cancel sec squared theta. Then we now have 1 over a, the integral of the theta, which is equals to 1 over a theta plus c. Then which is equals to, if you open the bracket, we now have 1 over a theta plus c. If you substitute theta, our theta is equals to 1 over a tan inverse of a over s plus c. Question 18. Evaluate the integral of 2s ds over s squared plus 5. Solution. S is equals to square root of 5 tan theta. If we draw our right angle triangle, then if we make theta the subject of the formula, we now have tan inverse of s over square root of 5. Therefore, the differentiation of the theta is 5 square root of 5 sec square theta d theta. Therefore, making the s the subject of the formula, we now have square root of 5 sec square theta d theta. Therefore, from the equation, we now have that s squared plus 5 is equal to 5 times square theta plus 5. Therefore, if you now bring out the common item, which is 5, and put the rest in the bracket, we now have 5 in bracket times square theta plus 1 is equals to, from the law of trigonometry, tan square theta plus 1 is sec square theta. Therefore, we now substitute tan square theta plus 1 to have 5 square sec square theta. Then from the question, we are asked to evaluate the integral of 2 ds over s squared plus 5. Therefore, to integrate, if you substitute the s, which you have gotten to be square root of 5x sec square theta d theta, and substitute our s squared plus 5, which we have gotten as 5 sec square theta, then we now cancel out. And if you do the integral of square root of 5, we'll still be left with an inverse of 5 square root of 5, which we now have 2 over square root of 5 integral of d theta, which is equals to 2 over square root of 5 theta plus c. Therefore, we give us 2 over square root of 5 times tan inverse of s over square root of 5 plus c. Question 19. Power of sine and cosine. Evaluate this integral of sine squared s ds. According to the law of trigonometry, sine squared s is equal to 1 minus cos 2s over 2. Therefore, we are asked to integrate sine squared s ds, which is equals to, if you substitute sine squared s, we now have integral of 1 minus cos 2s over 2 ds. Then if we integrate individually, we now have an in bracket 1 half over in bracket s minus sine 2s over 2 plus c. Then if we open the bracket, we now have half s minus sine 2s over 4 plus c. Question 20. Evaluate the integral of cos squared s ds. Solution. From the law of trigonometry, cos s is equal to cos 2s plus 1 over 2. Therefore, we are asked to integrate the cos squared s ds, which we now substitute cos squared s cos s to have integral of 1 plus cos 2s over 2 plus c. Therefore, which we now have half of s plus sine 2s over 2 plus c. Now open the bracket, we now have half s plus sine 2s over 4 plus c.